Welcome to Tiny Show and Tell Us, the bonus series where you write in with your favorite science story, fact, or piece of news. We read your email aloud and then dive deeper. I'm Sam Jones, the exec producer of Tiny Matters, and I want to give a big thank you to science writer and chemist Anne Hilden for doing the research for this episode. All right, today I'm psyched to be here with science communicator and producer George Zaidan. George, hi and welcome.
Hey, happy to be here hosting a few of these with you and diving into some show and tells from listeners. Before we get into things, though, just a reminder that Tiny Matters is always looking for you to write in because that's what makes future episodes possible. You can email us at tinymatters@acs.org or click the Google form link that we put in the episode description. All right, let's do this. And Sam, since I'm a first timer, I will let you kick things off.
How kind of you. So my Tiny Show and Tell Us is from listener Cecilia, and this is a really feel-good one. So I'm excited actually to kick things off today.
Excellent.
So Cecilia wrote in and said, when dogs see humans, their brains react, scanned via MRI, in the same way for love.
Oh,
yeah.
That's so feel-good.
I know. So I love this. And we actually have an episode from November 2023 called We Don't Deserve Dogs, The Science Behind the Human-Canine Relationship. So if you want to dive more into not just love from canines, but a bunch of other things, that's episode 46, if you want to check it out. I
Do the people know that you are a dog owner, Sam?
feel like they probably should know at this point. Because I can't shut up about it. No, I am a dog owner. I have 2 dogs. I'm obsessed with them. George, you're also a dog owner.
I am a dog owner and also obsessed with my dog. Just one, not 2, though.
Yeah, it's a little out of control for me at moments, but I've accepted my role as a crazy dog lady. Okay, so let's talk a little bit about this. So there have been a number of studies using fMRI to see what's going on in canine minds and the canine brain. So functional magnetic resonance imaging, or fMRI, it's non-invasive. It just really measures brain activity by detecting changes in blood flow. Some fMRI studies have focused on activity in the caudate nucleus. So this is a structure that's involved in the brain's reward system. So while the caudate nucleus assists in a bunch of different things like learning, motor functions, goal-directed actions, it is strongly activated by dopamine, and it's involved in attachment behavior. And so in animals, this correlates with motivation to engage with different objects or targets, depending on what species you're talking about. In humans, it's also said to correlate with romantic love.
Oh.
And so in her research into this topic, Anne came across a group of researchers who have done a lot of experiments in this area and working with dogs. And so I'm going to talk about some of the work that they've done. I'm talking about mainly this guy named Gregory Burns, who's a psychologist at Emory University, and he teamed up with a bunch of different colleagues, as well as a dog trainer, very important.
Oh, yeah, that's key.
Named Mark Spivak. The first task in all of this is to train dogs to lie perfectly still in an MRI machine.
That's very, very easy, as we all know, to get a dog to say, stay still.
Yeah, I know. So they were able to do this.
Wow.
And then confirm that they could actually detect caudate nucleus activation in dogs when they saw a hand signal that meant that a food reward was coming versus a signal that meant no reward.
Oh, interesting.
So there's actually, I'm going to really quickly, George, I'm going to share this with you.
Okay.
But if you just scroll down here, you can actually see a very cute photo of a dog named Callie lying in an fMRI machine.
We should actually note for everybody that the journal link you sent me is PLOS ONE, which is open access. So anyone can go and see this picture.
Yes. I will link to this in the episode description.
Oh my God, that is adorable.
Yeah, she's so cute. She's so cute. Like, my dogs would never, ever.
Oh, no. No. Also, MRIs are loud, as you are no doubt
so loud.
aware. Yeah, so
Yes.
This is impressive that she's just kind of so focused on is that the trainer in figure B?
That's not the trainer that I was mentioning. I'm not sure who that is. That could be one of their colleagues who they're working with, but she's so cute.
Yeah, so cute.
Okay, so back to the studies.
Back to the science.
We had to take a moment to look at that. Okay, so then they went on to measure whether the response was different depending on if the dogs received the hand signals from their handler versus a stranger. So does it make a difference if it's the dog's owner? The reward response was always bigger for food than no food, obviously.
Good, yeah.
So they found that the response was bigger when looking at a stranger in dogs that are more aggressive, actually.
Really?
Yeah. But for less aggressive dogs, bigger when looking at their handler. which I thought was really interesting. In dogs who are aggressive, you're seeing more activity, more of this brain activity when there's someone that they don't know, like there's a stranger. Versus dogs that are less aggressive, they're seeing like the biggest change when they're looking at their owner.
What is that? How do you interpret that? What does that mean?
Their main point in this is that response depends on canine temperament as well. Like, I think that was like their big message there. But I would think that you are seeing just as much intense brain activity in that region as a response, like a protective response, as you are a love response. And it just depends, like, what is the dog's default mode, maybe.
Oh, interesting.
I don't know. That's sort of my armchair expert interpretation of it a little bit. But it is really interesting. And also, I'm like, thank goodness for the canine handler, because if a dog is supposedly a bit more aggressive, how do you train that dog to be in an MRI machine to begin with?
Yeah, seriously. Actually, yeah, that's a good question. Like, how did they know which dogs were more aggressive than, I guess, the owner would tell them, I guess. Like, I think
that was part of it. I didn't go super deep into, like, all the methods of that article, but this is just kind of interesting. I'm, like, a little off the topic of love at this point, but I think it's also just interesting to know, generally speaking, what kinds of experiments people have done to try and understand what's going on in a dog's brain.
Yeah.
So I have a couple more of those, and then I'm going to talk about, I guess I can say love specifically, but it's like still a bit of a reach, but I don't know. I think it's real. I think dogs love us. We love them. Case closed. No. So then this researcher, Burns, and his colleagues also tested dogs' caudate activation when smelling the scents of familiar and unfamiliar dogs and humans.
Oh.
What they found was that the dog's reward response was the strongest when smelling a familiar human.
That makes sense.
As opposed to an unfamiliar dog or a familiar dog.
That makes sense, yeah.
Yeah. I wonder though, like, my dogs are so obsessed with each other that I wonder if they'd be like more excited to smell each other than me.
I was told when we were getting our dog, I was told not to get two dogs from the same litter because they would bond to each other more than they bond to you. So that would be an interesting experiment to run too.
That would be interesting because mine are not from the same litter. They're like a year and a half apart. Mm-hmm. But I feel like our older dog is like, this is my best friend / baby a little bit. Anyways, and then they actually did an experiment where they measured caudate activation in response to signals that meant that the dogs would receive food or praise. And they showed roughly equal or greater activation to praise versus food. That totally checks out with my dogs because they're really not very motivated by food. They're much more motivated by our response to them. But again, this is still, it's kind of a mixed bag with this.
Yeah.
So all of this definitely indicates that dogs can have this like very positive association toward their humans specifically.
Yeah.
And seeing them, smelling them makes them very happy. A lot of the time in a similar way that food makes them happy, and that there is still this varying level of attachment depending on the dog.
Yeah.
But there is one study that I feel like is the closest thing to being able to say that dogs feel love.
Okay.
And so in it, the researchers tested the effects of looking into your dog's eyes.
Oh.
So this is a study done in 2015. And I feel like my dogs stare into my eyes sometimes. And it's like, I love it so much.
Yeah.
And so what these researchers found was that when people look into their dog's eyes for 5 to 10 minutes.
Minutes?
Yes. Prolonged eye contact.
Wow. Okay.
And so, I mean, I'm sure, you're like looking around a little bit, but like you're really trying to maintain that eye contact.
Yeah.
What they find is that both dogs and people experience a surge of oxytocin.
Wow.
Oxytocin, of course, often called the love hormone, the cuddle hormone, the bonding hormone. Right. And there's no touching. It's just looking.
Oh, you're not even like holding your dog's head tenderly as you gaze into their eyes.
Which is usually the case.
Yeah.
It's like me holding my dog, kissing her face, looking in her eyes on repeat for 5 minutes until she's like, I'm good.
That is fascinating. So surge in oxytocin, meaning like they were doing blood tests during these? Okay.
Yeah.
Wow.
Which is so interesting.
It is interesting. And it's interesting. I'm glad they tested it in both the dogs and the humans because that result makes a lot of sense because you get a lot of like joy and satisfaction from looking at your dog's eyes.
Yeah, absolutely.
Yeah.
And then this is kind of fun. It's not love related, but I thought it was interesting. There are also fMRI tests that indicate that dogs can feel jealousy, which I think for any dog owner is like, okay. So in some dogs, they had a lot of amygdala activation while watching their caregiver give food to a realistic but fake dog when they put food in a bucket.
Oh my God.
Yeah, some weird jealousy thing going on. And so the amygdala, it's a structure that's deep in your brain. It's known to play a really important role in regulating aggression as well as fear. And so I thought that was fascinating. And then also a different group of researchers detected activation in a dog's amygdala, as well as a couple other brain structures, when they saw their caregivers interacting pleasantly with another dog. So that is not shocking to me, because when I go and like I'm out on a walk and I go pet another dog, immediately mine comes over and is like, I'm going to lean against you. And don't forget, you're number one.
Yeah. My dog growls when I like pet another dog.
So funny.
It's really funny. And I always playfully was like, oh, she's just jealous. But now I'm like,
she is
jealous. Yeah. That's proven.
Yes. So yeah, that's it. Thank you so much to Cecilia for that, because that was a really fun one to learn more about, even more than I learned in that regard, I guess, for the dog episode that I worked on last year.
That is a really fun one. So I'm going to take us from dogs here on Earth all the way out to space.
We have range.
I
like that.
Miles of range. This one is from Ben. And Ben writes, hemoglycin is a space polymer, which is just space polymer already, ! Present in areas where stars and planets are forming. In addition to faraway galaxies, the polymer likely arrives on Earth, piggybacking on the 5,200 tons of space dust that lands on this planet each year. Biochemists believe hemoglycin is present on Earth because stromatolites, possibly the first life forms on our planets, show traces of hemoglycin and likely used the polymer as an energy source. Now, using the James Webb Space Telescope, astrophysicists will try to detect hemoglycin as it forms, providing key information on the origins of life on Earth and other planets. There's a lot to unpack there. Let's just start with 5,200 tons of space dust falling on Earth every year.
No thanks.
So these things are called micrometeorites because that's what they are. They're tiny meteorites. Then they're so small that you need a microscope to see them. And a lot of them look like asteroids under the microscope. Like you see a picture of it and you're like, oh, that's an asteroid. And then you see the scale and you're like, it's like 90 micrometers. And you're like, oh no, that's a small speck of dust.
Yeah, that's maybe a grain of sand if we're lucky.
Yeah.
Yeah.
And so, 5,200 tons reaches the Earth's surface. That's out of a total of 15,000 tons that hits the Earth, and about 10,000 burns up in our atmosphere. So, whoa, a cicada just landed on the window outside of my...
I was like, oh, this is like dramatic effect for whatever George is going to say next.
Oh my God. And now I'm just looking right at the underside of a cicada. So that is gross. Okay, so space dust, hold that in your head. We're going to come back to it later. Okay. So hemoglycin, right? As you can guess from the name, it contains iron, and glycin is for glycine. That is an amino acid. And this thing is a polymer. So it has a well-defined structure. It is 2 chains of 11 glycines each of which is connected to make a small sheet with iron atoms at either end. And then that little subunit can link together to form really surprisingly complex structures like tubes, vesicles, things like that. And as Ben mentions, hemoglycin is found in space. We found it on 6 meteorites.
Wow.
These are the types of meteorites that formed about the same time as the planets in our solar system formed. So it's old. And now when I'm reading this, I'm like, wait a second, is this evidence of like life in space? Because it's an organic polymer, it has iron. Here on Earth, we have organic polymers with iron proteins, but alas, it is not evidence for life. And the reason it's not is actually really cool, is that it can form abiotically, which means it can form just spontaneously on its own. It's not produced by life. It is formed in the cold, nothing darkness of space. And also, as Ben points out, hemoglycin is found on Earth. It's been found on many meteorites, but recently researchers reported finding it in a roughly 2 billion year old fossil, a fossilized stromatolite in Montana. A stromatolite is a rock that was made by a microbe, which sounds super weird, right? But you're nodding your head. You've heard of these things before? Okay, so I'll tell you, you correct me if I'm wrong then. Basically, it's photosynthetic microbes congregate together in biofilms. Those biofilms trap sediment, and that sediment hardens to form a microbial mat. And you get layer upon layer upon layer upon layer of that over time, a lot of time, and eventually you have a rock.
Okay, yeah.
Does that sound right?
That makes sense, yeah.
So you can find them being produced on Earth today, but there were lots more produced many, I guess, millions, hundreds of millions, billions of years ago, before more complex life on Earth took over. And they give us a peek at some of the earliest life forms on Earth. So what is hemoglycin doing in a stromatolite? The answer is we don't totally know. Like, it could be that the microbes used it as food. It's got an amino acid in there. It's got organic carbon. It could potentially be used as an energy source. But the researchers who wrote this paper came up with like a super wild theory, which I'm going to tell you.
Okay.
2 billion years ago, there was the Great Oxygenation Event, which is when the Earth's atmosphere went from having no oxygen to having a lot of oxygen. Not as much as we have today, but a lot. And they noted that this stromatolite that they found was found right in the middle of this GOE, Great Oxygen Event. And so they were like, hemoglycin can catalyze a transformation of water into hydrogen peroxide, which then breaks down to form oxygen. So maybe this stromatolite kicked off the Great Oxygenation Event.
Oh, wow.
That's just a they did quantum mechanical modeling. They did no like bench work to, to validate this. But it's super interesting. Maybe that is why we have oxygen on Earth today, or one of the reasons.
I love a wild theory because I feel like as long as I'm not talking about like wild conspiracy theories. I'm talking about a wild theory that has some scientific basis to it, because I feel like at the very least, it gets people excited and thinking about it and thinking about how they might design better experiments to test that. I feel like it's more a way of getting people's minds going and, leading to some research that wouldn't exist unless someone came up with a semi-wild theory about how the Great Oxygenation Event happened.
Totally. So that's hemoglycin. It comes to us from Ben. Ben also wrote that the James Webb Telescope would be looking at how hemoglycin forms. I wasn't able to find that, but I didn't do a ton of research. So Ben, if you're listening, send us the link and we'll put it in the show notes.
Perfect. Thanks, George.
Thank you. Thanks for tuning in to Shiny Toe and Tell. Nope, that's not
Shiny
right at all.
Toes and Tell Us.
Shiny Toes. Oh, man. Thanks for tuning in to Tiny Show and Tell Us, a bonus episode from Tiny Matters, a production of the American Chemical Society.
To be featured in a future episode, send us an email with your Tiny Show and Tell Us at tinymatters@acs.org, or click the Google form link in this episode's description. See you next time.